So let's start our class. So good morning, guys. So welcome to NEET World Institute and NEET World YouTube channel. So in this class, yes, we are going to continue with the topic of this Newton's law of motion. So yesterday we were talking when the acceleration is not acting on a body, how to take the free body diagram and what are the forces we need to consider, how the forces will be considered when we take an object with respect to the surfaces, everything we have seen. And today we will talk about the problems. So from the basic problems we will start, like when a force is applied on an object, what will be the normal force between the two blocks, everything we will see, right? Yes. So let's start from the basic concept. I guess screen is visible, right? And I'm audible, I guess. Okay. Done. We'll start with the problems. Okay. Suppose there is a surface, okay, and what I am doing is we have taken two blocks, the block number 1, that is capital M, and other block small m I will take. Now what I am doing is I am applying a force on this object. I am applying a force on this object, in the sense like I am applying the external force. Okay. So what happens? This blocks will move in the right direction with the acceleration A. We don't know that acceleration. We need to find that acceleration. That's the question. When the object is moving, in between there is a attachment. Right now, like it has been attached with the block M and M, small m and capital M. So it doesn't separate. It doesn't separate, which means there is some force is acting on block M and block small m also. What is that force also we need to know. Okay, let's find out the free body diagram for the first one, capital M. So what are the forces are acting? When I talk about the normal force and the weight, it will cancel each other because it doesn't lift. It is not lifting. Right now it is going in this direction. I am talking about only x direction. Okay. So when this force is acting like this, what will be the normal for capital M? It will be perpendicular to the small m. So I can say this is my normal force. And what is the direction they have given? It is very important, like I need to mention the direction of the acceleration to solve the equation. I will tell how to take the equation when the acceleration is given. Okay. The next one is small m. So when small m is there, like normal force will be acting in this direction. So in between this normal force is there, now it will be equal for capital M as well as small m. Okay. So what is the direction? This is my direction. Okay, done. Now if I want to write the equation, what I should do is I need to find which direction the acceleration is going. Okay, right direction. So in that direction any forces are acting for the block A, that is M. Yes, only one force, that is external force. Write that force first. Okay, in the opposite of the acceleration, whatever the forces are there, you should take in negative. So F minus N will be equals to, this is force, should be equals to, force will be equals to mass into acceleration. What mass? Capital M, and the acceleration A. Okay. The next one is, this is my direction and this is the force, only force. So N will be equals to small m into A. This is my equation 1, this is my equation 2. if I see, if I add the equations, no, minus n and plus n will get cancelled off. F will be equals to capital M into A plus small m into A. So what I will get here, I can take the A commonly outside from the given terms. M plus M will be equals to F, right. So A will be equals to, what is A? A will be equals to F divided by capital M plus small m. This is my acceleration of the given system. Got it? Okay. Now if I want to find the normal force acting between them, it is simple, n equals to ma, that's it. For both it is same. I have told whatever the normal force acting between this block will be same for capital M, will be same for small m. So I can consider n is equals to m into A. Got it? Yeah, which m I need to take, that also I should see, small m into A. Okay. If I talk about here, F minus ma will be my normal force. Okay. Now I will take the condition 3 blocks. M1, M2, M3. Now this is my force. Which force is this? External force. Okay. Now what is the acceleration? First question. What is the acceleration? This is my first question. Second question, what is the normal force acts between like M2 and M3. I am talking about M2 and M3. Okay, this is my question. So for the first question, what we will do? We will draw the free body diagram, right? Free body diagram in the sense, let me take the M1 block. What are the forces are acting in the x direction I am talking, okay, x direction. So what are the forces? One is external force F and other force is there. So this is block M1. So this is my surface M2. So M2 will be acting like the normal force will be acting in this direction. Let me take this is N1. Is there any other forces? No. When a force is applied in this direction, acceleration will be in this direction. If they have not mentioned about the acceleration, you should consider the acceleration direction based on the given external force. Okay. The next one is M2. So when I talk about M2, a normal force is there based on M1, a normal force is there based on M3. So this is my N1, the normal force due to M1, and other one, that is N2, the other normal force, N2 due to M3, right? Acceleration direction will be in this direction A. Then now the last one is M3. So this is my normal force due to M2. Is there any other forces acting on M3? No, only this. And what is the direction? This is my direction A. Okay. So what did I tell? Like whenever the diagram is there, see the direction of the acceleration. In that direction, whatever the forces are present, that forces will be considered as a positive. In opposite direction, it is negative. So F minus N1 will be equals to M1A. Then this is my equation 1. Second equation, N1 minus N2 will be equals to M2A. Equation 2. Third equation, N2 will be equals to M3A. Okay, sir. What we can do over here means, I can add the equation, I can add everything. If I add everything, minus n1 plus n1 will get cancelled off, minus n2 plus n2 will get cancelled off, f will be equals to m1a plus m2a plus m3a. So, I can take a commonly outside, m1 plus m2 plus m3. So, which is nothing but a will be equals to f divided by m1 plus m2 plus m3. So, from the given observation from like in this question or the previous question, what we can understand is acceleration is nothing but the force divided by the sum of mass in the system. Okay, the sum of mass we should write it. Okay, this is about the thing. That's the first question. Second question, what they have asked here, find the normal force between m2 and m3. Between m2 and m3 it is n2. So, I can say directly it is m3a, or else normal force n2 is equals to m3a, or else I can say n2 is equals to n1 minus m2a. What is n1? Again, n1 it is nothing but f minus m1a. F minus m1a minus m2a will be equals to f minus m1 plus m2 times a. This is my n2 in terms of force and m1 and m2. This is in terms of m3 and only m3. Got it? So, we have solved the first question as well as second question. So, we will see now what is the thing is a block upon the block. Now, block in the adjacent side we have talked. Now, block upon the block. Now, there is no acceleration, but what will be the normal force we will talk. Okay. So, once you have completed, we can go for the next one. Done. So, the next one is now I am considering a block M1, the other block M2. So, what is the normal force between M2, and if I consider M3, what is the normal force between M2 and M1? What is the normal force between M3 and M2? If I talk, this is my block M1. What are the forces are acting? Like two normal force, because one is surface, one is the surface of the M2. So, due to surface, I will take N. Due to the M2, I will take towards down, because it will be acting perpendicularly, no. So, due to M2 it will be down, that is N1. And what else is there? Weight is there. So, weight will be acting towards down, that is M1g. That is it. We have talked about the whatever the force acting here, right. Now, if I write the equation, how we can write the equation? N will be equals to N1 plus M1g. So, what is N? N is the normal force between the M1 and the surface. Okay, sir. We want the normal force between M2 and M3. That's the thing you are asking, right? So, then I can write like in this also. N1 will be equals to N minus M1g also I can write it. That also correct. Now, if I talk the M2 block, what are the normal forces? Due to M3 one normal force, due to M1 one normal force. So, due to M1 we have considered already, that is N1. So due to M3 we will consider that is N2, and one more thing is weight, M2G. So from here I can say N1 will be equals to N2 plus M2G. N1 will be equals to N2 plus M2G. Here it is based on the normal force between the surface and the M1. It is based on the normal force between, what is the thing, M2 and M3. Got it? So the final thing is M3. So for M3 only one normal force, that is due to M2, that is N2, and one weight is there, M3G. So the normal force is nothing but N2 will be equals to M3G. These are my equations. These are my equations. Done? Okay. So the next one we'll see. When a block is attached with a rope. So let me consider this is M1 and this is M2. And what about this one? It is some force is acting, we will take. What force, sir? External force also it can be. External force. Okay. So now what is the thing is, I need to find what is the tension acting over here. What is the tension? So how many ropes are there, sir? Only one rope. It is between M1 and M2. We are taking this one as a force applied. Okay. By hand also we can pull it. Okay. Now I will draw the free body diagram. Okay. I will take this one M2. So which direction the force is acting? Towards right, F. So if I talk about the tension, in which direction it should be? Away from the object. Away from the object, T. Acceleration direction, right side. That's it. If I talk about this M1, so tension will be away from the object, T. Acceleration direction, this one, A. Okay, sir. Now whatever I have told in the first problem, try to remember. Direction of acceleration, I need to consider the forces positive. In the opposite direction, it is negative. So F minus T will be equals to M2A. For this one, T is equals to M1A. If I add both of them, minus T plus T will get cancelled off. F will be equals to M2A plus M1A. It is nothing but A times of M1 plus M2. So similarly we will get, yes or no? We are getting similarly, no? A will be equals to F by M1 plus M2. మరి ఎందుకు సార్ మనం ఇది కూడా డిరైవ్ చేస్తున్నాం, మరి సేమ్ ఫార్ములా అని చెప్పేసి వెళ్ళిపోకూడదు కదా అంటే, if suddenly they are asking what is the tension acting in the equation, what you will do, right? So that is the thing I have explained here. Like if we talk about a basic problem, we should have a clarity what are the things are acting over here. Okay, so tension is nothing but it is a rope. In the rope it will be acting, but normal forces, like when the contact surface is there, then we are talking about a normal force, right? But the same thing only, same kind of concept only. Okay, you should see the directions, then analyze the equations. Don't try to memorize whatever the formula is given in this lesson, especially in laws of motion. Don't memorize the formula, just keep the concept in mind, try to apply the concept, try to apply the rules and solve the equation. Okay, done. So we will see for the three blocks, in between two ropes will be there, that also we will see. So this is my M1, this is my M2, this is my M3. Now the force is acting like this. If I consider what force I told, external force. Okay, so what will be the free body diagram if I draw here for the M1? For the M1, what are the forces? One is external force F, tension away from the body, this is my T. The first rope, second rope, okay, the first rope, okay, T1 I will take. What is the direction? Acceleration will be in this direction. I will go for the second one. This is my M2. So, two ropes are acting. One is T1, one is T2. So, T1 will be in this direction, right now. So, this is my T1, this is my T2, but acceleration is, if M1 is going like this means M2 also, M3 also will be in the same direction. So, this is my acceleration. So, for M3 how many ropes are there? Only one rope. So, this is my M3 and this is my tension T2. Acceleration direction, that is it. Once you have drawn, like completed the diagram, no diagrammatic part, it is easy to analyze. So, acceleration direction, force is positive, F is positive, opposite direction, force is negative. So, minus T1 should be equals to M1A, force should be equals to mass into acceleration. Got it? Now, the second one, T1 minus T2 will be equals to M2A. Now, the third one, T2 will be equals to M3A. If I add everything, T1 minus T1 plus T1 minus T2 plus T2, everything get cancelled off, F will be equals to M1A plus M2A plus M3A. Done? So, if I take A commonly outside, what happens? A times of M1 plus M2 plus M3. So, A will be equals to F by M1 plus M2 plus M3. So, is this looking similar? Yes, it is looking similar with the second problem whatever we have done. Okay, done. So, now we will talk about the pulley problem, okay. M1 and this is M2. Suppose consider M2 is greater than M1. M2 is nothing but mass, M1 is also nothing but mass only. Suppose M2 is greater in the sense, M2 will try to go down, M1 will try to go upside, no. So, this is the direction of the acceleration, right. So, how many ropes are there in between M1 and M2? Only one rope. Got it? Now, if I talk about the free body diagram, M1. So, weight will be there. Sorry, I will talk about okay, whatever it is, no issues. M1 I will take, M1 only. Weight will be there, okay, fine. Weight I have taken, M1G. What about the tension? Acting away from the body, so it will be like this, T. Acceleration direction towards up, okay, fine. I have taken acceleration direction according to the equation. What about the next one? M2 is there. If I talk about M2, so weight will be there for M2, M2g. What about the tension? Tension is acting away from the body, which is in the upward direction, T. So what about the acceleration direction towards down? So if you notice, M2 is going down, M1 will be obviously and automatically it will go up, right? So what I have told, acceleration direction I should check. In the acceleration direction, force is positive, opposite direction force is negative. Simple trick to remember, okay? So for this one, T minus M1g will be equals to M1a. Tension minus weight will be equals to mass into acceleration. For this one, M2g minus T, M2g positive minus T should be equals to M2a. If I add both of them, what happens? If I add both of them, tension and tension will get cancelled off. This one is M2g minus M1g equals to M1a plus M2a. Got it? So from this, I can take g commonly outside. M2 minus M1 times g should be equals to M1 plus M2 times a. Okay. So if I want acceleration, what I should take? Keep the acceleration one side, remaining term the other side. A will be equals to M2 minus M1 by M1 plus M2 into g. This is my acceleration. This is my acceleration. So for M2 different acceleration, for M1 different acceleration? No. Whatever the acceleration M2 is going, the same acceleration M1 is going upward. Okay, that's the thing we should concentrate here. Okay, so with this I'll end up the today's session. Okay, and we'll meet in the next session, guys. Until then, I'll take a break from you. Bye bye.